Today we're going to look at perpendicular vectors on page 6 of the notes. And I asked in the example, find a vector perpendicular to the vector 3 miles, comma, negative 5 miles. So we can see that the vector that's given is given to you in a rectangular or in a component form. So I graphed the original vector, right 3, down 5. I put it in standard position with its tail at the origin. Recall that you don't have to have vectors in standard position, but it's just a lot of times easier to work with them that way. So if I want a vector that's perpendicular, I have to think back to what we know about slopes. If two lines are perpendicular, we know that their slopes are opposite and reciprocal. So if I look at the change in y over the change in x of the original vector, it has a slope of negative 5/3. Therefore, any line or any ray vector that is perpendicular to it will have to have a slope that is opposite and reciprocal, so 3/5. There are lots of ways to write 3/5. 6 over 10, 1.5 over 2.5, negative 3 over negative 5. So we actually have a variety of vectors that we could write that are perpendicular. The directions don't actually give us what the length needs to be of the vector. We just need to have the vector need to be perpendicular. So one vector that will work will have the component form being 5/3. That would have a slope of 3/5. Or negative 5, negative 3. That would have a slope of 3/5. You can see that the one vector, 5/3, will point up in this direction. The other will go in the opposite direction. Both are perpendicular to the original vector. We could modify the lengths of these vectors by multiplying by different factors out in front. We could make them unit vectors, but this would suffice. Either one of these would suffice to give us a vector that is perpendicular to the original one. If, on the other hand, our vector is given in a polar form, which would also work for common form as well, then it's actually a little bit easier to find a perpendicular vector. I drew the original vector, 12 miles per hour, the angle being polar, so going from the positive x-axis, rotating counterclockwise, and I have this as the original vector. I can see that there would be two vectors as far as how they point that would be perpendicular, one going up in the second quadrant, one going down in the fourth quadrant. And in either case, I don't know how long to make the vector. That's my choice. I chose to write two vectors that were both the same length as the original vector, both being 12 miles per hour, so these are velocity vectors, and then added on 90 degrees to find the vector that would be over in the second quadrant, and subtracted away 90 degrees to find another vector that's perpendicular to the original, and that would be at a negative 20 degrees for a polar angle. So in general, if you're given vectors in component form or rectangular form, you want to think of drawing the picture of the vector, recognize there's more than one vector that is perpendicular, but we want the slope of your vector to be opposite and reciprocal. So this would need to be the new slope, with a negative either in the top or the bottom. And so you'll get a couple of answers that would work that would be the same length, and then there are infinitely many answers that are perpendicular that are different lengths.